Hello everyone. In this video, we will learn about Bayes theorem. What is this Bayes theorem? Bayes theorem is named after Reverend Thomas Bayes, and this work was published in 1763. So basically in probability theory and statistics, this Bayes theorem, you can sometimes it is called as Bayes law or Bayes rule. It describes the probability of an event based on prior knowledge of conditions that might be related to the event. What does it mean? It is this Bayes theorem is based on conditional probability. So let us understand this Bayes theorem by means of an example. So we'll just consider an example of tossing two coins. So when you toss two coins, what are the events that can occur? It can be either both the coins having head, or you can have head and tail, or you can have tail and head, you can have tail and tail. So this is the sample space which you have, that is the occurrence, the events which is occurring when you toss two coins. So the probability, what is the probability of getting two heads? You can see that here how many events are present in the sample space. 1, 2, 3, 4, 4 events are present. So out of this 4 events, how many events are having both head? Only one. So what is the probability of getting two heads? It is 1 by 4. Now let us see the second probability. Probability of getting at least one tail. What is the meaning of this? At least one tail means when you are tossing two coins, at least one of them should give you tail. So when you see this event, the sample space, you can see here this is having tail, this event is also having, this is also having tail. So there are 3 events which is having tail. So how many total events are there? 4 events are there. So the probability of getting at least one tail is 3 upon 4. Now the next case is probability of second coin being head given the first one is tail. What is the meaning of this? It is given that the first coin is already tail, and then what is the probability that the second coin will give you a head? So the first one is tail is already given. So first one tail, you just observe the sample space. First one tail is this one is 1. Then here you have one more. So how many events are there with first coin giving tail? 2 coins. So we are supposed to find the probability of second coin being head. So out of these 2 events, you can see that only one is having second one head. So what is the probability of the second coin being head given the first coin is tail? So here out of 2 only 1. So you are getting 1 by 2. Now consider the fourth one. The probability of second coin being head given the first one is head. What is the meaning of this? The first one is already given head, and you are going to find the probability that the second coin will also give you head. So the first one head, you have here one case, one event is there. We have another event here. So total 2 events are there with the first coin giving head. So out of that, the second coin giving head is only one there. So what is the probability that the second coin will give you head given the first coin has already given you head? That is 1 by 2. Why 1 by 2? Because there are only 2 events in which the first coin has given head. So you are supposed to find both the second one also head. That is both head. So that is only one event occurring out of 2. So 1 by 2. So this is a normal probability. So you can see that the first 2 probabilities here, that is the normal probability you are finding. But this third and fourth case, you can see you are finding the probability given some condition. So this last 2 cases, you can say it as a conditional probability. So basically what I was talking is this Bayes theorem is based on conditional probability. So the last 2 cases, you can call it as conditional probability cases, wherein which we can apply Bayes theorem. So Bayes theorem gives the conditional probability of an event A given another event B has occurred. So this I have already explained by means of tossing the coins. So this is the equation for finding the probability. You can see here this probability of A by A given B. So probability of A given B is nothing but it is a conditional probability. Given B is you are, something is given, that is condition is given. So that is why it is called as conditional probability. So probability of A given B is, it is a conditional probability of A given B has already occurred. What is this one? That is nothing but that is equal to probability of B given A. That is the conditional probability of B given A. that into probability of A divided by probability of B. So here probability of A given B is called posterior, probability of B given A is called likelihood, probability of A is called prior probability, probability of B is called evidence. So this is basically the Bayes theorem equation. So this equation will be using to find the conditional probability. So we just consider the same example, that is tossing two coins. Already we have the sample space like this, and what we are going to do is we are going to find the conditional probability. So let us call this A as an event that the second coin is head. So the second coin giving head, we are calling that as an event A. So we call that as an event A, that is the second coin giving head. And what is B? B we are calling as the first coin giving tail. So the first coin, if it is giving tail, we are calling it as event B. The second coin giving head, we are calling it as event A. So we are going to find the probability of second coin being head given the first coin is tail. So what is that one? Second coin being head. Second coin being head, we are calling it as event A. And given us what? Given us first coin is tail. So we already, this is given, first coin is tail is already given, that is B, event B is given, and you are going to find the probability of A given B. A is what? For event that the second coin is head. So we are going to find probability of A given B. So that is nothing but this is the equation for Bayes theorem. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. So what is this one? Probability of B on A. B is what? That is the first coin is giving tail. And what is A? A is the second coin giving head. So we are finding the probability of first coin being tail given second coin is head. So that is what this B on A. So that one into probability of A, that is second coin being head. Probability of A, second coin being head. And first coin being tail. First coin being tail. So first one, the probability of the first coin being tail given second coin is head into probability of second coin being head divided by probability of first coin being tail. So that is this P of A divided by P of B. So what is that one? First coin being tail given second coin is head. Second coin is head, and first coin being a tail. So only one is there. So 1 by 2 into second coin being head. Second coin being head also again it is 1 by 2, and first coin being tail, that is also 1 by 2. So you are doing 1 by 2 into 1 by 2 divided by 1 by 2. You got the answer as 0.5. So you can check that one here. We already got this value as 1 by 2. This one as 1 by 2. So using the Bayes theorem formula also we are getting the same answer. So this is how you can use Bayes theorem for finding the conditional probability. So this theorem, this formula, actually it calculates the conditional probability of occurrence of an event based on prior knowledge of conditions that might be related to the event. So you can actually write this equation. You can otherwise write like this. In words you can say it as posterior is equal to likelihood into prior divided by evidence. So this probability of A is called prior probability, and probability of B is called evidence. This is called prior probability. This one is called evidence. This one is called likelihood, and this is called posterior probability. But what are these terms? Prior, evidence, posterior, likelihood, and all. We will see that one. So posterior probability is something, it is the updated probability after the evidence is considered. So as you know, this one is posterior probability. So this one is what we are going to find. So what is that? Based on the evidence we are finding this probability, right? So this probability is nothing but it is the updated probability after the evidence is considered. Now what is prior probability? Prior probability is something, that one is nothing but that is this P of A is prior probability. That is a probability before considering evidence. So this is a normal probability P of A before considering the evidence, that is prior. And P of A by B, that is posterior, is what? After considering the evidence. And P of B is what? That is our evidence. So that one is prior probability is, as I already said, that is P of A, that is the probability before the evidence is considered. What is the likelihood? Likelihood is the probability of the evidence given the hypothesis is true. So this one is the likelihood. We can say this is the likelihood. So that is the probability of the evidence. So this is the probability of the evidence given the hypothesis is true. And marginal probability, you can say marginal probability, or you can say it is evidence. There is a probability of evidence under any circumstances. There is the probability of evidence under any circumstances. That is the denominator term here. So this one is evidence, probability of evidence. So this is the explanation of various terms associated with Bayes theorem. Now let us again consider one example in which we consider three boxes, A, B and C, three identical boxes. Okay, let us assume that box A contains 2 red and 3 black balls. Okay, and box B contains 3 red and 1 black ball. Box C contains 1 red and 4 black balls. Okay, so these are the balls present in box A, B and C. Now the even or the evidence is that a red ball is chosen. We are assuming that the red ball is chosen, and what we are supposed to do, we are supposed to find the probability that this red ball belongs to box A. So now the evidence you have, the event is event you are considering is the red ball. We are choosing the red ball, and we are going to find what is the probability that this red ball is chosen from box A. So that is what we are going to find. Now let us call this event as E. What is the event? That is the red ball is chosen, and we are going to find whether that chosen ball is from box A. As you know that there are three boxes, all boxes are identical. So the probability of picking the prior probability is what? Before the evidence. So the prior probability is probability of choosing A, probability of choosing B, probability of choosing C. They are having equal probability. So three boxes are there. So each one, the choosing a box will be 1 by 3. So choosing box A will be, the probability will be 1 by 3. Box B will be 1 by 3. Box C will be 1 by 3. So this is the prior probability you are getting. Now, because all the boxes have equal probability of getting picked. Now what we are supposed to find? We are supposed to find this one. What is this one? That is the probability of event E. Given event E, what is E? E is the probability that red ball is chosen. And what we are supposed to find? We are supposed to find whether that red ball is chosen from box A. So we are going to find probability of A given E. That is nothing but probability of E given A into probability of A divided by probability of E. So, but you need to know all this terms. So, P of A is nothing but 1 by 3 we already found. Now, what is this probability of E of A? What is that? It is now probability of E of A is the number of red balls in, what is this E? E is number of red balls. What is A? That is box A. So, number of red balls in box A. What is the number of red balls in box A? You can see here in box A, it consists of 2 red and 3 black balls. So, what is the probability of picking a red ball from box A? So, how many total balls are there? That is 2 plus 3. 5 balls are there. Out of that, 2 are red. So, the probability of choosing a red ball from this box A is 2 by 5. So, here it is 2 by 5. And what is the probability of choosing a red ball from box B? That is 3 by 4. Why it is 3 by 4? 3 plus 1, 4. Total 4, and out of that 3 are red. What is the probability of choosing red ball from box C? It is 1 by 5. Okay, so we got all this one, the probability of choosing a red ball from each boxes. So now here we got this one 2 by 5, here 3 by 4 and 1 by 5. So now what is this evidence? So probability of evidence, that is the event E. Event E is what? The probability of choosing red ball. What is, how will you find that probability? That is nothing but probability of E given A. That is this one 2 by 5 into probability of A. That is what? This 2 by 5 into probability of choosing red ball. So 2 by 5 into probability of choosing red box is 1 by 3. So plus a probability of that red ball from box B into probability of choosing a box B, probability of choosing box B plus the probability of choosing red ball from box C into probability of choosing that box C. So you got this one. So this is what is that one, that is 2 by 5 into 1 by 3 plus 3 by 4 into 1 by 3 plus 1 by 5 into 1 by 3. You got the answer is 0.45. What is this one? This is the probability of that occurrence of the event. What is that event? Event is probability of getting a red ball. That is the event E. E is red ball is chosen. And we are supposed to find whether this red ball is chosen from box A. So what is that box? Probability of getting a red ball, probability of choosing a red ball from box A, that is nothing but probability of E upon A into probability of A divided by probability of E. So probability of E on A we have already found, that is 2 by 5 here. So we'll substitute that one here into, what is this probability of A? Probability of A we already found, it is 1 by 3. So into 1 by 3 divided by the probability of event, that is E, that is red ball. So what is that one? That is 0.45. So that 0.45. When you substitute these values, you are getting it as 0.296. So we have got the probability of choosing a red ball from box A. That is already, see, the probability of getting a box A, if the event already occurred is red ball, and we are going to find the probability of getting that from box A. So the red ball was picked out of box A, probability is 0.296. So this is the direct application of Bayes theorem. We got the probability. So this is nothing but it is the conditional probability. This is how we apply Bayes theorem for finding the conditional probability of any event. So there are various applications of this Bayes theorem. We can, when the conditional probability of an event is given, then we can use this Bayes theorem to find the reverse probability of the event. So this can be used for understanding the probability problems in medical field, or you can use it for statistical modeling and inference. Then most commonly it is used in machine learning algorithms, in classification problems and all. You might have seen Bayes classifier. Then we can use it for quantitative modeling and forecasting. So several applications are there. It has vast number of, where as you can see that you can find any probability given an event has occurred. That is, you can easily find the conditional probability using this Bayes theorem. So I'll explain how we can use this Bayes theorem in a Bayes classifier in the upcoming video. Hope you understood this, the basics of Bayes theorem. Thanks for watching. Thank you.